Bonjour. Hi, everyone. This is Judith from ELCC. Today, joining the AI Biostats podcast with Darko. Hi, Darko. Good afternoon. How are you
Hello,
doing?
Judith. It's great to speak to you at the podcast.
Yes, today we don't have Bruno. He's voiceless, but happy to join you in a podcast indeed. We have been working together for some years now with around AI, biostats, pseudo IPD data, network meta-analysis data, many other projects, but have not had the chance yet to join a podcast with you. So happy to talk today live to everyone who might be listening in. And today, the topic that I wanted to discuss with you, Darko, was about network meta-analysis. What do you think?
I think it's a great idea, and really thank you so much. It's really great to do a podcast with you and our great executive producer Shahir. So thank you very much. I think it's a super important topic, and we have been doing a lot of research into this field lately. We discussed with our audience before in a number of podcasts network meta-analysis, how it works, and the principles introductory. But what we haven't really discussed, we haven't really went too much into that field, how AI could help us there, how a large language models could potentially help us there. So if you agree, I think it would be an interesting topic to discuss.
Definitely. Indeed. So we are at this intersection of synthetic evidence data, right? So like leveraging all the data that we currently already have available to derive some indirect evidence that could give lots of information and power to the additional power to the data that we already have available, right? So we have been working a lot around pseudo individual patient data, right? And creating those synthetic individual patient data, pooled KM curves, and such. But also now talking about this synthetic evidence at the network meta-analysis level, right? And we have been working on some key populations. And like, would you like to explain what we have been digging and how we are using the different LLMs to power that network meta-analysis that we can conduct with all the hazard ratio data that we would be having in Clean indeed?
Yes, actually, I think that is probably one of our most advanced approaches in the NMA field. And as you said before, an extensive research has been done into this topic. So what makes NMA very complicated is the fact that in an NMA we have so many different study designs, so many different regimens. There's actually even if we have, like, LARVOL has one of the largest, probably the largest oncology database in the world. But even if you have a largest oncology database in the world, you don't have everything inside. Like, there's always external information that is not in your database, that you can find in some research paper, or that you can maybe find on clinicaltrials.gov, which has been published on some. We do a lot of information retrieval from conferences and abstracts, but there is always a chance that you might need some additional information. So you might want an agent to go outside your database and actually also reason about all the information that you have inside the database and help you make some decisions. Like, because this yeah, sorry, please go ahead.
Indeed. So no, indeed, building on that, like we do have like around 104,000 trials in Clean, and hazard ratios not 20K but almost there, so 20,000. So how to leverage on that power, right? So how to put together all that knowledge to extract some indirect evidence and do some inference on like those data points that would not have been directly compared and that could be comparable, right? Like with all the cross trial comparison limitations, like we need to always be aware and conscious of that there's lots of power information that we can extract from those analysis and connect the
Yes,
dots.
yes, that's actually one of the main reasons why we even started this project, if you remember, Judith. And there is just so many things that could be automated. and the scale is so large that just going manually and doing all these things manually just doesn't make sense. Of course, there are maybe some critical points where we want to do things manually, but eventually we would want AI to actually just like take 100 trials and
Mm-hmm.
assess those 100 trials for transitivity. For just for our audience, transitivity is we basically want to see if the trials are comparable to each other, if they're similar enough to be put into the same network meta-analysis. And basically, imagine a situation where I would have to go manually through 100 trials and see if they are comparable. That would just take months probably. And
Exactly.
the AI can narrow this for us. So that's one of our that's what we are doing right now. We are actually implementing the AI agents that can do this for us. Of course, at the end of the
Mm-hmm.
day, we would jump in as humans to actually just check everything. But that's one of the approaches where LLM, of course, there are things that for special reasons maybe we cannot discuss in finest detail right now. But uh, uh, that's probably one of the key areas where we just need an
Mm-hmm.
LLM to just go large scale and retrieve all the relevant information in these trials and tell us how comparable their
Mm-hmm.
study designs are.
Indeed. So indeed, like in the network meta-analysis that you were sharing in your screen before, like certainly what we have done would be basically like to fill in that data, that those clinical trials that we know that are having clinical outcomes. So we would be filtering, fitting it into the LLMs, identifying which would be the has the trials that would fit into that key population description, right? And see if they they pass that transitivity selection, right, process. And then also we work on a consolidation step, right, because we know that it's not that easy or that straight forward to make that network to be connected with all the regimen, all the variability, all the terminology that it's being used. So we add also that extra layer of information that helps you also power that network.
Exactly. So what people are seeing, and I saw that we got message from Bruno. So hello, Bruno. We're really sorry that you cannot be with us today, but we feel your support, definitely. Uh, and I just want to say that, this network meta-analysis is actually a product of hundreds of trials being initially there. And then the AI actually assessed each one of them and filtered a group of trials that are comparable enough to go
Mm-hmm.
together into the NMA. And this courtesy is a work of our highly respected scientist and one of the key figures in this project, Samina Paraven.
Yes.
So she created this NMA, and basically it's like this would take 2 or 3 months for a researcher to go through all those 100 trials, and Samina was able to do this, I think, maybe in 30 minutes or 1 hour, but by leveraging all these agents to do that for us.
Indeed. So she would be like what she does, if we can add some more color, would be evaluating those features, right, that define key population. So line of therapy, the biomarkers and alterations, the disease, of course. So also the stage. So while we're talking about advanced, metastatic, early stage. And on top of that, we're also now evaluating the transitivity. So like going beyond into these baseline characteristics or the inclusion criteria that is behind that clinical trial. And then we get to the level of the consolidation of the regimens, so we can get this connected network. Even it's very interesting, so to be able to do this consolidation at different levels, right? Because you can see times where the consolidation could be at the level of the specific chemotherapy, just go with chemotherapy as a regimen, or even when you are able to compare first generation TKIs against third generation TKIs, right? So it's very interesting to have that freedom and that power also in your hands, so you can run the research question or the approach that you would be mostly interested in, right? And in here we are seeing the regimen ranks indeed.
Yes. So as you said, we get the regiment rankings very quickly, and all those nuances that are in between, especially in the regiments where a regiment may be so complicated. Like if you remember, Judith, in the first versions of NMA, when we actually created it, like
Were
some regiment
unreadable.
names, yeah, they were so large that they actually could not
I
fit
remember.
yes, they could not fit on someone's screen. Like they were like,
Adjusting the plot, adjusting the names. Yes,
yes.
I
So,
remember.
yeah, so now we have AI doing that for us. Like, it will consolidate. If the regiment name is too long, it will just consolidate it to a meaningful, comparable
Exactly.
regiment to all other regiments. So,
Yes.
yes. So
And
right now,
standardize it only commercial, only generic, so you can really identify and pull what's relevant to the case.
yes. So those are the two steps that we have been mostly experimenting with and now building in public
Yes.
with everyone from our audience. And if you have any interesting suggestions or comments,
Yes.
please, we would welcome all of them, and would answer to all of them. Uh, the two steps that currently LLM and agents are doing for us are trying to gather as much as information on these trials and help us decide on the transitivity. So we still make the final decision, right? So we don't let the LLM do everything, because
Mm-hmm.
we believe that human AI interaction is very important. We don't want to leave everything to AI just yet, even though
We're
as
leveraging, yes, balance, finding the right balance, right, to get that connectivity work, to get that, like, if you were seeing in the, now, right now in Clean, we are putting those NMAs that we have been at what we call LM assisted NMAs, right? They help us in trial selection, doing the transitivity, the consolidation. So we are building those NMAs for the key populations. And it's very interesting to see that in the connected network, we get to see those regimens that are FDA approved or that would be SOC. So that's what you're expecting to see, right, in the network meta-analysis. So we're in the right direction, keep improving, but yes, it's being very interesting and exciting, that LLM assisted NMA.
Yeah, so it's an exciting combination of AI and statistics, where on one side we actually have the statistical part is done using a validated statistical package. So we still don't trust, and I don't know what you think, Judith, on there. Do we still do we trust LLMs to do statistics 100%?
Um, it's complicated. I'd say we did the test. It didn't work as good as we would have expected, unluckily, unfortunately. So yes, like right now, I would rely more on that package that we have put together in Clean.
Yes. So now I'm going to use a term that Bruno really hates, and he's going to judge me now when I say this. It's actually,
I'm just seeing him
what?
run by
Yeah,
here.
he's watching right now. I'm 100%. And so what we are doing is we are using this hybrid model. So on one side, it's doing this transitivity and regiment consolidation. That's what AI is doing with a
Mhm.
little bit of our help. And the other part, which is the pure mathematical statistics, where it actually needs to use validated packages and
Software.
formulas, that's where we actually have the full statistical software from our
Yeah.
programming
With
language.
net meta, net split, like
Yes,
all the validated softwares that are
yes,
very well known and commonly used, right, by the statistics. Yeah,
yeah. So,
statistical
so
team.
it's currently that balance of, we can trust AI to do this, and where we cannot trust AI, we just need to use that standard approach that is
Sure.
currently
Yes.
established.
So hopefully, we will share more news on NMA soon, and maybe I have the luck also to join another podcast with you, Darko. So it was very nice discussing with you, and hope you also enjoyed listening in. And I think that's my time for au revoir, as Bruno used to say, as always. Thank you very much,
Yes,
Darko.
thank you so much, Judith. It was really fantastic to join you in this podcast, and also Shahir. And thank you so much. I want to thank everyone from the audience, and hope it was interesting. Again, feel free to leave any questions, comments, even after the podcast is complete, and also an au revoir for me.
Bye.